We are going to start now lecture 4 of chapter 9 class 11th mathematics sequence and series. In this lecture we will talk about the arithmetic mean and related problems. So we are saying suppose we have three numbers. These are the three numbers we are saying. It is small a, then capital A and B. These three numbers are in AP. Then we say that this capital A that we have, it is the arithmetic mean between A and B. So we are saying these three numbers, these are in AP. So this thing implies us that A minus A, that is equal to B minus A. So this thing implies us that 2 times A is equal to A plus B, and this thing implies us that capital A is equal to A plus B by 2. So what we obtain from this is that the arithmetic mean between A and B, it is A plus B by 2. So the first question we have based on this, that find the arithmetic mean between 14 and minus 6. So the answer we will have, it is 14 plus minus 6 by 2, and that comes out to be 4. Next is, these are the two numbers given to us, A minus B and A plus B. So if we calculate the arithmetic mean between these two numbers, we will have the answer, it is A minus B plus A plus B divided by 2. So this B and B gets cancelled. The answer we obtain, it is A. So we are saying that A is the arithmetic mean between A minus B and A plus B. Next is, if this number A raised to the power n plus B raised to the power n over A raised to the power n minus 1 plus B raised to the power n minus 1, it is arithmetic mean between A and B, we have to calculate the value of n. So it is being given to us that A plus B by 2, that is equal to A raised to the power n plus B raised to the power n over A raised to the power n minus 1 plus B raised to the power n minus 1. Now if we cross multiply these terms and multiply the terms over here, we will obtain, it is A raised to the power n plus B raised to the power n plus B A raised to the power n minus 1 plus A B raised to the power n minus 1, that is equal to 2 times A raised to the power n plus 2 times B raised to the power n. Now look at these terms over here. We are writing, it is B raised to the power n, this term is there, this term is over there. So it becomes minus B raised to the power n plus A B raised to the power n minus 1, that is equal to A raised to the power n minus B raised to the power B into A raised to the power n minus 1. Now if we write B raised to the power n minus 1 common from both these terms, we will obtain, we are writing B raised to the power n minus 1 common from this term. We are left with is A minus B, and we are writing this is equal to, we are writing A raised to the power n minus 1 common from these two terms. We are left with is A minus B. Now clearly we have A is not equal to B, because we are saying if A and B they are equal, then the arithmetic mean will be equal to both of them. So we are saying that these two terms gets cancelled, because we are saying that A is not equal to B. So what we obtain from this is that B by A raised to the power n minus 1 is equal to 1. So this thing implies us that n minus 1 is equal to 0. So the value of n we have, it is equal to 1. So we have to calculate the value of n. The value of n we obtain, it is equal to 1. Next is n arithmetic means between A and B. So n arithmetic mean means, we are saying A is a number, B is over there. We have to insert the numbers over here, A1, A2, A3, so on up to An. We have written these numbers, and this whole sequence, it forms an AP. Then we are saying that these n numbers, A1, A2, A3, so on up to An, these n numbers, these are the n arithmetic means between A and B. Now suppose we are given two numbers A and B, and we have to insert n arithmetic means between these two numbers. Then the method we have is, we have two numbers A and B, and we have to insert n arithmetic means over here. So we are saying this is an AP whose first term is A. The number of terms we have over here, it is n plus 2, and the common difference we have over here, it is say D. So we are saying that this is an AP. So what we obtain from this is that the nth term we have, n plus 2th term we have, we are talking about Tn plus 2, that is equal to B, that is equal to first term plus n plus 2 minus 1 D. So this implies us that B minus A is equal to n plus 1 D. So this implies us that D is equal to B minus A over n plus 1. This is the value of D that we have. Now if we want to write any general term over here, so what we will obtain is that An, the nth arithmetic mean, that is equal to A, the first term, plus n, we are talking about the nth term over here, minus 1 into D. So when we are talking about the An means when we have over here it is A1, A2, A3. So when we are talking about A1, so this is the second term. When we are talking about A3, this is the fourth term. If we are talking about An, so it is basically the n plus 1th term. So that is why we will have n plus 1 minus 1. Over here we will have it is n plus 1 minus 1, and the answer we obtain it is n, and the value of D we have it is B minus A over n plus 1. So the final answer we obtain is that the nth arithmetic mean between these two numbers An is equal to A plus n into B minus A over n plus 1. So this is the nth arithmetic mean between the numbers A and B. Now next we have is insert 6 arithmetic means between 15 and minus 13. Now the value of D that we will have, we are saying what we have to do, it is 15 over here, 13 over here. We have to insert 6 arithmetic means, so it is A1, A2, so on up to A6. This is the first term A, this is the last term 13. So this is basically the 8th term. So we are saying the value of D that we will have, that is equal to B minus A over n plus 1, that is equal to minus 13. This value we have it is minus 13. Then it is minus 15 over 6 plus 1. So the answer we get over here it is minus 4. So this is the value of D that we obtain. Now we want to calculate the value of A1, A2, A3. So the value of An that we will have, that will be equal to A plus nth term, it is n minus 1. We are saying when we are talking about An, so this is basically the n plus 1th term. So we will have n into D is minus 4. So the value of A1 we will have, that is 15 minus 4, that is equal to 11. The value of A2 we will have it is 15 minus 8, that is equal to 7. The value of A3 we will have it is 15 minus 12 is equal to 3. The value of A4 we have it is 15 minus 16 is equal to minus 1. Then A5 we have it is 15 minus 20 is equal to minus 5. And the value of A6 we have, that is equal to 15 minus 24 is equal to minus 9. So these are the 6 arithmetic means between 15 and minus 13. Next is, if m arithmetic means are inserted between 1 and 31, we are saying it is 1 and the last number it is 31, and the arithmetic means to be inserted there, m arithmetic means, it is A1, A2, so on up to Am, and it is being given that the ratio of the 7th and the m minus 1th mean is 5:9. It is being given that A7 over Am minus 1 is 5/9. Now we have to calculate the value of m. So from this result, from what is given to us, the first term A we have it is 1, this last term we have it is B, value of B we have it is 31. So the value of D we have, that is equal to B minus A over m plus 1. So this is equal to 30 over m plus 1. Now we have to calculate the value of A7. So A7 is basically the 8th term of this AP. So it is A plus 7d. So answer we obtain it is 1 plus 7 into d is 30 by m plus 1. So the answer we obtain that is equal to m plus 211 by m plus 1. Next we have to calculate is a m minus 1. So it is the mth term. So it is a plus m minus 1d. So it is equal to a plus m minus 1 into 30 by m plus 1. And on solving this we will obtain it is equal to 31 m minus 29 by m plus 1. Now it is being given that a7 is to a m minus 1, that is equal to 5 by 9, and the value is equal to m plus 211 divided by 31 m minus 29. Now if we cross multiply these terms, the final answer we obtain, the final equation we will obtain, it will be 155 m minus 145, that is equal to 9 m plus 1899. And if we solve this equation, we will obtain the value of m is equal to 2044 by 146, and the value comes out to be 14. The value comes out to be 14. So this is the value of m that we have. Next we have is if x, y, z are in AP and A1 is the arithmetic mean between x and y, A2 is the arithmetic mean between y and z. So it is being given that x, y, z, these three numbers, these are in AP. It means we have the value of 2y is equal to x plus z. Next it is given that A1 is the arithmetic mean between x and y. So we obtain that 2a1 is equal to x plus y. Next is A2 is the arithmetic mean between y and z. So we obtain 2 times A2 is equal to y plus z. We have to prove that the arithmetic mean between A1 and A2 is y. So if we are calculating the value of A1 plus A2, it means we are adding both these equations. We will obtain 2 times A1 plus 2 times A2, that is equal to x plus 2y plus z, and the answer comes out to be equal to, we are using this equation over here, the answer we obtain, it is equal to 4y. So this implies us that a1 plus a2 is equal to 2y, and this thing proves that the arithmetic mean between a1 and a2 it is y. Next we have is if the arithmetic mean between the pth and qth term of an AP, suppose we are saying the pth term we have, it is TP plus TQ by 2. This is the arithmetic mean between pth and qth term, that is equal to the arithmetic mean between the rth and the sth term. So it is equal to TR plus TS divided by 2. We have to prove that P plus Q is equal to R plus S. So suppose the first term we are writing, this AP we are talking about, it is the first term is A and the common difference is D, and the number of terms it has, it is say N. Then the value of TP, that is A plus P minus 1D plus A plus Q minus 1D, that is equal to A plus R minus 1D plus A plus S minus 1D. So A gets cancelled, this A gets cancelled, and from all these terms we will obtain that P minus 1 plus Q minus 1 minus R plus 1 minus S plus 1 into D is equal to 0. Now clearly this D we are saying it is not equal to 0 because it is an AP. Common difference cannot be 0, otherwise it will become constant. So this 1 and 1 get cancelled, minus 1 and 1 get cancelled. So what we are left with is that P plus Q minus R minus S is equal to 0. So this implies us that P plus Q is equal to R plus S. So this is the answer we are obtaining over here, that P plus Q is equal to R plus S. Next is the nth arithmetic mean between 20 and 80 are such that the first mean is to last mean is equal to 1:3. We have to calculate the value of n. So the first number given to us, it is 20 and the last one is 80. Now we have to insert n arithmetic means. It is a1, a2, so on up to the last one, it is an. Now it is given that a1 is to an, that is equal to 1:3, and we have to calculate the value of n. The value of d we have, it is 80 minus 20 by n plus 1, that comes out to be 60 over n plus 1. The value of a1 we will have, it is, that is equal to t2, that is equal to a plus d, that is equal to 20 plus 60 by n plus 1, and the answer comes out to be 20n plus 80 by n plus 1. Now the value of an that we will have, that will be equal to tn plus 1, that is equal to 20 plus nd. Answer we will obtain, it is 20 plus n into the value of d that we will have, it is 60 over n plus 1. The answer we obtain, that is equal to 80n plus 20 divided by n plus 1. Now we are being given that a1 is to an is 1/3. We are using this result over here. So we get, it is 20n plus 80 divided by 80n plus 20, that is equal to 1/3. So when we simplify this, we are left with this n plus 4 divided by 4n plus 1, that is equal to 1/3. On cross multiplying, we will obtain 3n plus 12 is equal to 4n plus 1. On solving this, we will obtain the value of n is equal to 11. So this is the required value of n that we will have, that is n is equal to 11. Next is, if n arithmetic means are inserted between two numbers, prove that the sum of the means equidistant from the beginning and the end are constant. So suppose we are saying that a1, a2, so on up to an, these are the n arithmetic means that are inserted between the numbers a and b. Then clearly this is an AP. Now we are saying the mth mean from beginning plus mth mean from end. We are saying this is equal to, when we are talking about the mth mean from the beginning, we are talking about a plus mth term means m into d plus, and we are saying mth term from the end, we are talking about the value we will have, it is b plus m d, and it is not plus over here, it is minus, because it is, we are talking about from the end. So sum of both these value will be a plus b. Suppose we are talking about m plus 1th mean from beginning and m plus 1th mean from end. The values we will have, it is a plus m, this is m plus 1th mean we are talking about, plus 1 d, plus, this is for m plus 1 mean from the beginning, and from the end it is b minus m plus 1 d. Again these two terms gets cancelled and the answer we are left with is a plus b. So in all these cases we are saying the constant answer we are getting, it is a plus b. So we have proved that the sum of the means equidistant from the beginning and the end is constant. Next is, show that the sum of n arithmetic means between two numbers is n times the single arithmetic mean between them. So suppose we are saying we have two numbers, first is this A and last it is B, and the arithmetic mean between these numbers it is A1, then A2, then so on up to AN. These are the n arithmetic mean between these numbers. Clearly this forms an AP, and the common difference of this AP, we know it is given by D is equal to B minus A over n plus 1. Now we have to show that the sum of the n arithmetic means, sum of the n arithmetic mean means we are talking about A1 plus A2 so on up to plus AN. This itself it is an AP, and the sum of this AP that will be given by n by 2 into A1 plus AN, sum of the first term and the last term. So this is equal to n by 2 into A plus, when we are talking about A1 this is basically T2 and this is Tn plus 1. So when we are writing T2, so it is 1D, we are talking about A plus D, then it is plus, when we are talking about this term it is A plus N D, and this thing we can write this is equal to n by 2 into A plus N plus 1 D. And what is A plus N plus 1 D? It is n by 2 into A plus B. The value of A plus N plus 1 D, it is B. This is basically the Tn plus 2, and Tn plus 2 is equal to B. So we are saying that the value of A1 plus A2 so on up to AN, that is equal to n by 2 into A plus B, that is equal to n into A plus B by 2, that is equal to n into arithmetic mean between A and B. So we are saying the sum of n arithmetic means between A and B is n times the arithmetic mean between A and B. Now the next question we have is, if A, B, C are in AP, we have to show that B plus C, C plus A and A plus B are in AP. So it is, we are saying A, B, C are in AP, it means we have 2 times B, that is equal to C plus A, that is B is the arithmetic mean between A and C. Now we have to prove that these two are in AP. So suppose we are calculating the value of C minus C plus A minus B plus C. The answer we will obtain, that is equal to A minus B. If we are calculating the value of A plus B minus C plus A, the answer we will get, that is equal to, on solving these two values, this A get cancelled and we are left with this B minus C. Now from this first result, we can write that B minus C is equal to A minus B. From this result we can use this. So what we obtain is that A minus B and B minus C both are equal. So this implies us that both these values, that is the common difference, the difference between these two terms D, that is equal in both these cases. So we are saying that these three numbers, these are in AP. Now next we have is, we have to prove that these three terms, that is A square B plus C, B square C plus A and C square A plus B, these are in AP. So again we are calculating the value of B square into C minus C plus A minus A square into B plus C. When we solve this value, we will obtain it is B square C plus B square A minus A square B minus A square C. So we can write it is C into B square minus A square plus, from these two terms we can write A, B common and we are left with this B minus A. So this is equal to B minus A into, from this term we will get it is C into, it is B plus A plus AB. So this is equal to B minus A into AC plus AB plus BC. Similarly, if we calculate the value of C square into A plus B, minus b square into c plus a. We will obtain this is equal to the value we will have over here, it is c square a plus c square b minus b square c minus b square a. So this is equal to a into c square minus b square, and next we will have it is plus bc into c minus b. So we can write this is equal to c minus b into ac plus ab plus bc. So this part in both these cases, ac into ab plus bc, and this part over here, both these parts, these are equal to each other. Both these parts, these are, this portion we are saying, this portion is equal to each other. Now we are left with this again b minus a and c minus b, and we have already seen that b minus a and b minus c, both these values, these are equal to each other. So what we get is that difference of these two terms, that is equal to difference of these two terms, and hence we obtain that these three we are having, these three numbers we are having, they form an AP. Now next we have is, if A, B, C are in AP, we have to show that these three numbers, these are also in AP. So again, if these three A, B, C are in AP, so we will have 2B is equal to A plus C, or we are writing that B minus A, that is equal to C minus B. So we have to prove that these three are in AP. So we are first calculating the value of 1 over, it is comma over here, square root of C plus square root of A minus 1 over square root of B plus square root of C. So if we take the LCM over here, we will obtain the value, it is square root of B plus square root of C minus square root of C minus square root of A divided by square root of C plus square root of A into square root of B plus square root of C. These two terms get cancelled, and we are left with this square root of B minus square root of A divided by square root of C plus square root of A into square root of B plus square root of C. Next, if we calculate the difference of the other two terms, we will have 1 over square root of A plus square root of B minus 1 over square root of C plus square root of A, that is equal to, we are taking again LCM over here, it is square root of A plus square root of B into square root of C minus square root of A, and in the numerator we are left with this square root of C minus square root of B. Now next, suppose we are equating both these values. We are talking about this is one value, this is the second value, and we are equating both these values. We are saying if these will be equal, we are saying square root of B minus square root of A divided by square root of C plus square root of A into square root of B plus square root of C, that is equal to square root of C minus square root of B divided by square root of A plus square root of B into square root of C minus square root of A. Now if we multiply this term on this side and this term on this side, what we will obtain is that A minus B over square root of C plus square root of A, that is equal to B minus C over square root of C, we have multiplied this term, it is square root of C plus this term over here, it is plus over here, plus square root of A. Now we have this result that B minus A is equal to C minus B. It means A minus B is equal to B minus C. We are talking about this first result. We are saying these two will be equal because of this result. So we have obtained that these three numbers, they are in AP. Next is, if A, B, C are in AP, we have to prove that these three, these are in AP. So again, if A, B, C are in AP, we will have B minus A is equal to C minus B, and from these results, when we are calculating, it is C plus A square minus b square, and then we are calculating minus b plus c square plus a square. So we are getting it is c plus a plus b plus c into c plus a minus b minus c. Then we are taking minus sign common. What we obtain from this is b square minus a square, so it is b minus a into b plus a. So from this term, this c gets cancelled, and from both these terms, if we take this a minus b common, what we are left with is this. First we are writing a minus b common. From the first bracket, we will have a plus b plus 2c, and from the second bracket, we are left with is plus b plus a. So the answer we obtain it is a minus b into 2a plus 2b plus 2c. Next, when we are calculating the difference of these two terms, we are having a plus b whole square minus c plus a whole square minus c square plus b square, that is equal to a plus b plus c plus a into a plus b minus c minus a. Then if we are writing for these two terms, we are writing it is plus b minus c into b plus c. So this a and a gets cancelled. We write b minus c common, and we are left with this 2a plus 2b plus 2c. Now look at these two terms. This is a minus b and this is b minus c. We are having this term is a minus b and this term is b minus c. So we are writing over here that both these values a minus b and c minus b, both these are equal. So using this result, we can see that both these values, these are equal to each other. So we are saying that the difference between these two, it is constant. So we are saying all these three terms, they are in AP. Next is, if A, B, C are in AP, we have to show that 1 by BC, 1 by CA and 1 by AB are in AP. Now it is being given that A, B, C are in AP. We know that if we divide any numbers in AP by a constant number, say we are dividing it with A, B, C, A, B, C, A, B, C, what we will get? We will get the sequence 1 by BC, 1 by AC and 1 by AB, and this will form an AP because all these three numbers, they are divided by a fixed number A, B, C. Next we have to prove that A into 1 by B plus 1 by C and all these three terms, they also form an AP. So look at these terms over here. If we write them in this form, it is A into C plus B over BC. Next we have is, we can write this is AC plus AB by BC. Similarly, the next term will be BA plus BC by AC, and next will be CB plus AC by AB. Now if we subtract 1 from all these terms or we add 1 to all these terms, we are adding 1 to all these terms, what we will obtain is that AB plus BC plus CA divided by BC, this is in AP, or we are just dividing it by this, adding this number 1 to all these terms, we are getting it is AC plus BA plus BC by AC, then it is AB plus BC plus CA by AB. Now look at these three terms. We are saying if we start with the number A, B, C, we are dividing it with the number ABC, we are obtaining 1 by BC, 1 by AC and 1 by AB. Now if these are in AP, this thing we have already proved. Now if we multiply all these numbers with a fixed number AB plus BC plus CA, we are multiplying all these three with a fixed number AB plus BC plus CA, AB plus BC plus CA, AB plus BC plus CA, then the resulting these three numbers we have, these are in AP. If we subtract a constant number 1 from all these, we will obtain the given numbers and they will form an AP. So, these three given numbers, they are in AP. Now, the next question we have is, it is being given that these three A square, B square, C square are in AP. We have to prove that these three numbers are also in AP. So, suppose we are saying that these three numbers, they are in AP. So, what we will have, if these are in AP, if 1 by C plus A minus 1 by B plus C, that is equal to 1 by A plus B minus 1 by C plus A. Now, this implies us, this is possible if we are having, in the denominator we have C plus A into B plus C, and in the numerator we will have B minus A, and we are saying this should be equal to A plus B into C plus A, and in the numerator we will have over here C minus B. Now, we are saying this thing is possible if this C plus A and C plus A gets cancelled. We are having B minus A over B plus C, that is equal to C minus B over A plus B, and this thing implies us that A square minus B square, or in place of A square minus B square we are having B square minus A square is equal to C square minus B square. So, what we obtain from this, we are being given that A square, B square, C square are in AP. It means B square minus A square is equal to C square minus B square. If A square, B square, C square are in AP, we are having this result. So, we are saying these two are equal. So, what we obtain is the difference of these two values, it is equal, that is all these three numbers, these are in AP. Now, next we have is, it is given that A square, B square, C square are in AP. We have to prove that these three numbers are in AP. So, suppose we are talking about these three numbers first. It is A by B plus C, B by C plus A, and C by A plus B. Now, if we add 1 to all these numbers, what we obtain is that A plus B plus C divided by B plus C, A plus B plus C divided by C plus A, and A plus B plus C divided by A plus B. What we are doing over here, suppose we are saying if these numbers A by B plus C, B by C plus A, and C by A plus B, if these three numbers, these are in AP, then the numbers obtained by adding 1 to it, they are also in AP. It means we are saying these three numbers are also in AP if these three are in AP. Now, if we divide all these numbers by A plus B plus C, what we are saying, that 1 over B plus C, 1 over C plus A, and 1 over A plus B will be in AP. We are saying this thing holds if these three numbers are in AP. And we have already proved in our previous question that if A square, B square, C square are in AP, then this thing implies us that these three numbers are in AP. This thing implies us these three numbers are in AP, and this thing implies us that the given three numbers, they form an AP, and this is what we have to prove. Next is show that these three numbers are in AP if A, B, C are in AP. So, again, suppose we are saying these three numbers, they are in AP, then what we will have, C square plus AC plus A square minus A square minus AB minus B square, that should be equal to B square plus BC plus C square minus C square minus AC minus A square. Now this a square get cancelled, this c square get cancelled. So what we are left with is, look at this term over here, we are left with this c minus b into c plus b. From these two terms, if we take a common, we are left with this c minus b, and we are saying this should be equal to b minus a into b plus a, and if we take c common, we are left with this b minus a. So this thing implies us that c minus b into a plus b plus c, that should be equal to b minus a into a plus b plus c. So we are saying that these three numbers, these will be in AP if this thing holds, that is if these two values are equal. Now it is being given that A, B, C are in AP. So if A, B, C are in AP, it means B minus A is equal to C minus B. Both these values are equal. C minus B and B minus A are equal. We are having A plus B plus C and A plus B plus C are equal. So if both these values are equal, we are getting that these three numbers, they are in AP. Now next we have is, if B minus C square, C minus A square and A minus B square are in AP, we have to prove that these three are in AP. So if these three values that are given to us in AP, what we will have is that C minus A square minus B minus C square, that is equal to A minus B square minus C minus A square. So this gives us C minus A plus B minus C into C minus A minus B plus C, that is equal to A minus B plus C minus A into A minus B minus C plus A. Now from the first two terms, these terms get cancelled, and what we are left with is that B minus A into 2C minus A minus B, that is equal to C minus B into 2A minus B minus C. Now we come to this part. We are saying that if these three terms, these are in AP, we are saying suppose 1 by B minus C, 1 by C minus A and 1 by A minus B are in AP. We are saying suppose this thing will hold if 1 by C minus A minus 1 by B minus C, that is equal to 1 by A minus B minus 1 by C minus A. Now if we take the LCM over here, this thing will imply us that B minus C plus A divided by C minus A into B minus C, that is equal to C minus A plus B divided by A minus B into C minus A. Now look at this numerator part over here. This numerator part, we can write this is A plus B minus 2C. This numerator part we are saying we can write it is minus 2A plus B plus C. Now clearly we will have C and A, these are not equal to each other because these are over here in the denominator. So the C minus A and C minus A gets cancelled. So what we obtain from this is that A minus B into A plus B minus 2C, that is equal to B minus C into minus 2A plus B plus C. Now if we compare this value with this given result, we are saying we can write this is B minus A into 2C minus A minus B, that is equal to C minus B into 2A minus B minus C. Now look at these two results over here. Look at these two values over here. This is one value we are saying, and this is the second value we are saying. By using both these results, what we obtain is that these three numbers that are given to us, 1 by b minus c, 1 by c minus a, and 1 by a minus b, are in AP. Now next we have is that if these three numbers, these are in AP, we have to prove that these three values, they are also in AP. So it is being given that a square plus 2bc, b square plus 2ac, and c square plus 2ab are in AP. Now if we subtract AB, BC and CA from all these three terms, this is a constant value, what we will obtain is, it is A square minus the term we will have, it is plus BC minus AB minus CA. Next is B square plus AC minus AB minus BA. Next is C square plus AB minus BC minus CA. We are saying these three numbers are given to be in AP. We have subtracted a constant value from all these three. What we obtain is that these three numbers that we have obtained, these are in AP. Now these are the formulas for these values. We are saying we have the formula, this is the formula for A minus B into A minus C. Next is the formula for B minus C into B minus A, and next is the formula for C minus B into C minus A. So what we have obtained is that A minus B into A minus C, B minus C into B minus A, and C minus B into C minus A, all these three, these are in AP. Now if we divide all these terms, with A minus B into A minus C into B minus C, we divide all these three terms with this value, we will obtain that the given three numbers, these are in AP. Now next we have is, if these three numbers, it is A square into B plus C, B square into C plus A, and C square into A plus B are in AP, we have to show that either ABC are in AP or AB plus BC plus CA is equal to 0. So we are being given that these three numbers, these are in AP. So we obtain that B square into C plus A minus A square into B plus C, that is equal to C square into A plus B minus B square into C plus A. So this implies us that B square C plus B square A minus A square B minus A square C, that is equal to C square A plus C square B minus B square C minus B square A. So if we look at these terms, from these two terms, from this and this term, we can take C common. We are left with is B square minus A square. From these two terms, we can write A, B common, and we are left with is B minus A. So if we write B minus A common, we get B minus A into C B plus C A plus A B, and we are saying that this should be equal to, again from these terms, look at this term over here, it is B square A, this is C square A. We can write this as A into C square minus B square minus BC into C minus B. So we get it is C minus B into AC plus AB plus BC. If we take C minus B common, we will have this term, it is plus over here. So we obtain that these two values should be equal, and these two will be equal if we have B minus A is equal to C minus B, or we will have the condition that AC plus AB plus BC is equal to 0. Now look at this condition over here, B minus A is equal to C minus B. What this thing implies? That 2B is equal to C plus A. So this implies us that A, B, C are in AP. This is the first part over here. And second part we have is that this term should be equal to 0. So we are saying that if this is an AP, then we have to show that A, B, C are in AP, or AB plus BC plus CA is equal to 0. Next is, if A, B, C are in AP, we have to prove that these two values, these are equal to each other. Now if A, B, C are in AP, we will have 2B is equal to A plus C. Now we need to prove this result. So we start with this value. It is 4 times B square minus AC. We can write this is 4 into B square minus AC. We can write it is 1 by 4 into A plus C whole square minus AC. What we have done, we have used this value over here. We are saying this 2B, in place of this 2B we have used this value. So what we obtain, this is equal to 1 by 4 is there. So we obtain it is A plus C whole square minus 4AC. So this is equal to A minus C whole square, and this is the left hand side of this equation. So we are getting that both these values, these are equal to each other. Next is, if A, B, C are in AP, we have to prove that A cube plus 4B cube plus C cube is equal to 3B into A square plus C square. Now from this result, we have B is equal to A plus C by 2. If we start solving this part over here, we will have 3 times, in place of B we are writing A plus C by 2 into A square plus C square. So this is equal to 3 by 2 into, if we multiply these values, we will obtain it is A cube plus C cube plus AC square plus A square C. Next we are saying, we are having, look at this right hand side over here, it is A cube plus 4 into, in place of B cube we are writing it is A plus C by 2 whole cube plus C cube. So we will get this is equal to A cube, again when we look at this value, it is A cube plus 1 by 2 times A plus C whole cube plus C cube. So this is equal to A cube, 2 times this, we are dividing it with 2. Then we are writing plus A cube plus C cube plus 3A square C plus 3AC square plus 2 times C cube. So on adjusting all these terms, we will obtain that both these values, these are, if you look at these terms over here, it is 2C cube and C cube, we obtain it is 3C cube. Next we have A cube plus 2A cube, we will have 3A cube. Next it is 3A square C and 3A square C, we are having this term over here. So what we obtain is that both these values, these are equal to each other. Next is, if Sn, Tn and D, these are the nth term, this is sum of n terms, this is the nth term, and this is the common difference of an AP, then we have to prove that D is equal to Tn minus 1 when n is greater than equal to 2. So we are saying the common difference we are calculating, this is basically the formula for common difference that we already know, that the difference between the two consecutive terms, that is constant, and that is called the common difference. Next, when we are talking about the second result, it is Tn is equal to Sn minus 1. This result we have already seen. We are saying what is sum of n terms? It is term 1 plus term 2 so on up to plus term n minus 1 plus term n. What is sum of n minus 1 terms? It is term 1 plus term 2 so on up to plus term n minus 1. Now if we subtract both these values, we will get Sn minus 1, that is equal to Tn. So this is our second formula. Now combining both these results, we will obtain that D is equal to Tn. In place of Tn we can write it is Sn minus 1, and then it is minus Tn minus 1. So Tn minus 1 is Sn minus 1 minus Sn minus 2. So the answer we will obtain, that is Sn minus 2 Sn minus 1 plus Sn minus 2. This is the common difference D that we have. This is the common difference D that we have. Next is, a sequence is an AP if and only if the sum of n terms is of the form an square plus bn, where a and b are constants independent of n. So it is being given that Sn is equal to an square plus bn. Now if we calculate the value of Sn minus 1, we will have it as a into n minus 1 square plus b into n minus 1. So if we calculate the value of Tn, we will have Sn minus n minus 1, and on solving this we will obtain this is equal to an square plus bn minus a into n minus 1 square plus b into n minus 1. So this is equal to a into n square minus n minus 1 square plus b into n minus 1. So this is equal to a into n plus n minus 1 into n minus n plus 1 plus b into 1. So this is equal to, this n and n get cancelled, 2n minus 1 into a plus b. We obtain this result. Now this is the value of Tn. Now if we want to calculate the value of D, it is Tn minus 1. So that is equal to 2n minus 1 a plus b minus 2 into n minus 1 into a minus b. So this gets cancelled. A is common. We are left with this 2n minus 1 minus 2n. Then it is plus this value, if we look at, it is 2n minus 2 minus 1. So it is minus 3. So this will become plus 3. So the answer we obtain from this get cancelled. We are left with this 2 times a, and it is a constant value. So we are saying that the given sequence we are talking about, whose sum is an square plus bn, it is an AP. Now if we talk about the converse part, we are saying that consider an AP with the first term a and common difference d. Now the sum of the first n terms, it is given by Sn is equal to n by 2 into 2a plus n minus 1 d. So we are writing this is equal to dn square by 2 plus a minus d by 2 into n, and we are writing this is an square plus bn, where the value of a is d by 2 and the value of b is a minus d by 2. We are saying the value of a and b we have, these are the two values that we will have. So what we can see from this is that if the value of Sn is 5n square plus 3n, then the value of Tn, if we calculate, that will be 5 into 2n minus 1 plus 3, that is equal to 10n minus 2. So what formula we are using over here? We are using that Ten is equal to A into replacing n square by 2n minus 1 plus coefficient of n, and d is equal to 2a. We obtain this result, and the value of d we will have it is equal to 10. This value we are saying. Similarly, in the second case it is minus 7n square. We can obtain this result in this form, and this is the value of a that we have. Then minus 18 is the value of d over here, and 8 is the value of d over here. So this is how, this is just the formula we have mentioned over here, that how you can calculate the general term or the common difference when the sum of the values it is given in terms of